Okay, this is fun. Let's do one more example. Example number two. Okay, it has two dependent sources, one dependent voltage source and another dependent current source. We are supposed to use the node voltage method to find the VO voltage. What's the VO in a phasor form? Similarly, what is the current IO in the phasor form? Okay, all of this is given. The simplest thing we can do is to start by naming the nodes. Okay, I'm going to call this node, I'm going to call this node 2. I'm going to annotate this one as node 1. Okay, all of this is node 1. Okay, you see at node 1, the voltage is V0 because that's the parallel voltage. Similarly, at node 2, the voltage is V1. So now we can start applying KCL at node 1. Okay, at node 1, if you look at the currents leaving, there is one current, there's a second branch, and there's a third branch. Let's add them up. The first branch current really is 32 I0. That's the current going down. Similarly, the second branch current is V0 by 25 ohms, right? Because this is V0, the voltage there. And if you think of this as ground, V0 minus 0 by 25 ohms. Okay, let's clean this up. I'm still going to call this as ground, 25 ohms. And what's the current in this branch? The current in this branch is V0 by negative J 50 ohms. All of that should equal 0 based on Kirchhoff's current law. If you write it in standard form, V0 1 over 25 ohms plus 1 over negative J 50 ohms, okay, plus V1 times 0 plus I0 times 32 is 0. Okay, so this is equation 1. You can plug that into MATLAB. Okay, so we are going to use MATLAB to the fullest extent without solving unnecessary mathematics. So KCL at node 2. Okay, what does KCL at node 2 say? This is node 2. There are three branch currents here. Think about it. There is one current that is entering and two currents that are leaving. Okay, so let us see if we can account for all of those. Okay, because this current is entering, I want to write it as negative 17 angle 0 degrees amperes. Similarly, the current that is leaving here is V1 minus 0 by 20 ohms. Okay, and the current that is leaving here is, pay careful attention, V1, that's the voltage there, and V0 over 4, that's the voltage there. Okay, so V1 minus V0 over 4 divided by J 40 ohms. All of that should equal 0 based on KCL. Okay, because we are applying Kirchhoff's current law, we add up all the currents that are leaving the node. Okay, now we can write this in standard form in the sense that factor out V0 negative 1 by J 160 ohms, okay, plus V1 times 1 by 20 ohms plus 1 over J by 40 ohms plus I naught times 0 equals to 17. Okay, 17 angle 0. Now, which is the same as 17. Now, this is my equation number 2. I'm just going to do this. Okay, equation number 2. There you have it. But the problem is, how many unknowns do we have? V0 is an unknown. Similarly, V1 is an unknown. Similarly, I0 is another unknown. So V0, V1, and I0. We have, it seems like, three unknowns. How are we to use two equations? So we need one more equation. So in order to, for the third equation, we need three equations, right? Three unknowns, three equations. For the third equation, we're going to use the constraint equation. Okay, by now we are familiar with the constraint equation. You see I0, this guy, the current that is flowing in here, the I0 current, okay, that guy is the voltage V1 minus this guy over J40 ohms. Okay, that's the constraint equation. I0 equals to V1 minus V0 over 4 by J40 ohms. That implies negative V1 plus V naught over 4 divided by J40 ohms all plus I naught equals to 0. So all I have done is taken this to the other side of the equation. Okay, we can write it in standard form V0 times 1 over J 160 ohms, okay, plus V1 times negative 1 over J40 ohms plus I naught times 1 equals to 0. There we have it. Here we have three unknowns and three equations. Sweet. MATLAB. Let me say that again. MATLAB should be able to solve this for V0, V1, and I0. Okay. So V0 will come out to be 1280 plus J 320 volts. Okay. V1 will come out to be 368 plus J 24 ohms, 24 volts, and I out will come out to be negative 1.40, negative J 1.20 ampere. So all of this will come out to be 1319,394 angle 14.04 degrees in volts. So V1 is going to be 368.782 angle 3.73 volts, and then the current is going to be 1.844 angle negative 139.40 amperes. What are we after, by the way? We are interested in calculating V0 and I0. Okay, sure enough, we have V0 expression here and I0 expression here in the phasor form. So these are the answers. Okay, all we have done is to apply KCL at different nodes to do the node voltage method. Pretty simple.